Hello everyone, my name is Tianyi Gu. I'm a sixth-year PhD at the University of New Hampshire. My research is about distributional methods for heuristic search. So intuitively, distribution is more informative than a scalar value. So we say that instead of guiding the search by a scalar heuristic, we can actually guide the search by a belief distribution that represent the uncertainty. We investigate this idea by two problem settings. The first one is real-time search, where the agent performs search for a bounded time before it commit a action. So when time is up, the agent have this search frontier which haven't reached the goal yet. So because of this bounded rationality, it actually have a value uncertainties. So how can we leverage this uncertainty to guide the search, right? So here's a troublesome example if we guide the search using scalar value. For example, the agent has two top-level action, alpha and beta, and it wants to decide should it expand nodes under alpha or under beta subtree, right? So say the agent has an expected cost under alpha and beta, and then the expected cost under alpha is actually lower than the expected cost under beta. Does it mean the agent have to expand more under alpha, right? Not necessarily, because if we can form a belief distribution around the expected value, and then if the agent is quite certain about the value in the alpha and quite uncertain about the value in the beta, in this case, it might be more important for the agent to understand the possibility that a poorly understood option beta can be actually have a lower cost than a well understood option alpha, right? So we cannot just rely on the expected cost scalar value. So we do need to consider uncertainty of estimates. Our approach does take that into account. So the second problem setting is a bounded cost search, which the agent is given a cost bound along with the problem. So the objective is to find a solution within the cost bound as quickly as possible. So the previous approach, potential search, does not consider search effort at all. And then the B's does not consider the uncertainty of its estimates. So it's very brutal. Now our approach consider both. Our approach is very simple. It's called expected effort search. It does three steps. The first is to estimate the probability of finding a solution within the bound. And given this belief distribution over the total cost and also the bound. And then it also estimates the search effort T, and then it does perform a best first search on expected search effort T over P. So if you're interested in my research, please stop by my poster. Thank you.